Welcome to the fourth lecture. In this video, I'm going to be telling you about speed, velocity, the different types of speed and velocity, the difference between speed and velocity, and I'll also brief you up about acceleration and the types of motion also. Okay, so let's start with speed. Speed can be defined as the distance traveled by an object divided by the time taken to travel that particular distance. It's a pretty simple definition, and I'm pretty sure that all of you know the meaning of speed. Now, when we take the formula of speed, speed is represented by the symbol V, and its formula is distance, which is represented by the symbol S, divided by time, T. So speed is equal to distance divided by time. Another thing about speed, it's a scalar quantity, and as I already told you, it's represented by the symbol V. Next, coming to velocity. Velocity is also represented by the symbol V, and its velocity can be defined as the displacement covered by an object divided by its time. So notice that I said for speed distance and for velocity displacement, because velocity is a vector quantity and the direction in which the object is traveling is very important to determine the velocity of an object. Even displacement is represented by the symbol S, so it will be S by T. Speed equals distance divided by time, whereas velocity equals displacement divided by time. So as if you watch the previous video, I gave you an example. So A to B, right? An object moves from A to B and then it comes back to C, right? So the distance between A and B is 10 meters and the distance between A and C is 5 meters. So we can say that the speed is 15 meter, right? So the distance is 15 meter and the time taken to travel that distance, okay, let it be 5 seconds, okay, 5 seconds to travel the whole distance. So divided by 5 seconds, so that gives us 3 meter per second. The main quantity is meter per second to represent speed. Now if we take velocity, the displacement covered by the object is -5, right? Because it's in the left direction and left is always minus. So the velocity will be -5 meters divided by how much time does it take? It's the same time. Even though the object doesn't actually move from only A to C, we have to take the time as 5 seconds itself. So the velocity will be -1 meter per second. So if we see the difference between speed and velocity, speed is a scalar quantity whereas velocity is a vector quantity. Speed is always positive whereas velocity is directed speed, right? So it's in a particular direction. And when there's direction, there's always positive and negative. So velocity can be positive as well as negative. So that's the difference between speed and velocity. The SI unit of both speed and velocity is meter per second. The regular unit which we take is kilometers per hour, but don't confuse yourself, the SI unit is meters per second. So let's now see the different types of speed and velocity. There are basically 3 types: uniform, non-uniform, and average of both speed and velocity. I'm taking it together. So if we take a look at uniform speed, when an object travels equal distances in equal intervals of time, then its speed is said to be uniform. So here's an object, okay, again A and B. Let's divide it, okay, so 10 meter in 5 seconds, 10 meter in 5 seconds, 10 meter in 5 seconds. So this object is traveling in uniform speed. Next, non-uniform speed, it's completely opposite to uniform speed. If the object travels unequal distances in equal intervals of time, then its speed is said to be non-uniform. So let's say it travels 10 meters in the first 5 seconds, and then 15 meters in the next 5 seconds, and then 9 meters in the next 5 seconds, then the object is said to be in non-uniform speed. You may ask me that first it's 10 and then it's 15 and then how can it go to 9? Like, how can it decrease? We are talking about the distance traveled in 5 seconds over here. So in 5 seconds, the speed will be something. Actually, it will be 2 meters per second. So it travels only 10 meter. Next, it will increase its speed. So it travels 15 meter. Then it again decreases its speed. It's at its lowest speed now. So it travels only 9 meters. So this may vary. And when it varies, it's called non-uniform speed. Next, average speed. So if a vehicle, it travels a lot of distance and it also stops when it's traveling. Okay, so for example, a bus is traveling from point A to point B. It stops at this point for a break and it stops at this point for another break. So in average speed, these breaks are not considered. And we say the average speed is the total distance traveled divided by the total time taken. So average speed, it's the formula is same, but here it's the total distance divided by the total time. So that's what average speed is. Next, we have instantaneous speed. Instantaneous speed is the speed of a body at a particular instant. So if an object is traveling from A to B, what's its speed at the instant of point C? If I say, then its speed will be 2 meters per second. And at the instant of point D, its speed may be 1 meters per second. So that's what instantaneous speed is, the speed of a body at a particular instant. I'm just pointing out a particular time and I want the speed of a body at that instant. That's called instantaneous speed. And then now we come to the types of velocity. It's pretty similar, but the only difference is uniform velocity. It travels equal distances in equal intervals of time in a particular direction. So if the body travels equal distances in equal intervals of time, but it changes its direction in the process, then it is not said to be uniform velocity. It will become non-uniform velocity. So if the direction of the body changes, even if it is traveling equal distances in equal intervals of time, its velocity will be non-uniform because velocity depends on direction. It's a vector quantity. So direction is very important in determining if a body is traveling in uniform or non-uniform velocity. So the direction should be same, then it's called uniform velocity. Non-uniform velocity, if the direction's not same, it's called non-uniform velocity. And yes, of course, if it's traveling unequal distances in equal intervals of time, then it's also said to be in non-uniform velocity. Average velocity is basically the same, but here the difference is it's the total displacement divided by the total time. And the symbols are the same because displacement is also represented by S. Next, instantaneous velocity is the same as instantaneous speed. I point out a particular instant of time and I want the velocity of the object at that particular time. That's called instantaneous velocity. Okay, so while we are at it and while we are discussing the types of stuff, let me just tell you about the types of motion. I know we discussed about rectilinear motion and curvilinear motion, but this is different. This is about uniform motion, non-uniform motion, and we don't have average and instantaneous motion. So motion, we have uniform motion and non-uniform motion. Uniform motion is when it covers equal distances in equal intervals of time, and non-uniform motion is when it covers unequal distances in equal intervals of time. Direction is not considered because motion, it's not even a quantity, right? It depends on various factors like distance and time and speed. So equal distances, equal intervals of time, uniform. Unequal distances, equal intervals of time, non-uniform. Okay, so that's about speed, velocity, their differences and their types. Now let's come to the next topic, which is really important, acceleration. Okay, so acceleration can be defined as the change in velocity divided by time. Or we can also say the rate of change of velocity is called acceleration. Acceleration between two particular points can be taken as, okay, so imagine a car. A car, it starts at rest. Okay, so its velocity is 0 meters per second. Okay, and then when it comes to B, its velocity is 5 meters per second. So the initial velocity, we call that U, is 0 meters per second, and the final velocity, which we call V, is 5 meters per second. So and the time taken, okay, let's say it takes 5 seconds, okay, to come from 0 to 5, it takes 5 seconds. So the formula for acceleration is V minus U by T. The final velocity minus the initial velocity divided by the time taken gives you the acceleration. Okay, so let me give you some examples for acceleration, and we'll also cover the types of acceleration, which are uniform and non-uniform acceleration. So in uniform acceleration, what happens is the object increases its acceleration uniformly. So first it starts off at 0 meters per second, and then after 5 seconds it comes to 5 meters per second. After another 5 seconds it comes to 10 meters per second. After another 5 seconds, 15 meters per second. So that is called uniform acceleration. The acceleration is increasing, but it's increasing uniformly. If the object is traveling at like a same speed, it starts at 0, and then it comes to 10. Let's say it comes to 10, and then it remains at 10 for 5 whole minutes. It remains at 10 meters per second. It keeps traveling at 10 meters per second for 5 minutes. Then the acceleration of the body, it's not there. The object doesn't even have any acceleration. The acceleration is 0 meters per second, because at for 5 whole minutes, the speed of the body is 10 meters per second itself, right? So till it goes from here to here, its speed will be 10 meters per second. So it doesn't increase, it doesn't become 11, it doesn't decrease, it doesn't become 9. So that's why we say that it does not have an acceleration if its speeds are not varying. And acceleration, it need not only be positive, because it can also be negative. So if the speed of a body becomes 0 to 5, okay, so it goes from 0 to 5, and then from 5 it comes to 4. If it decreases, then it's called negative acceleration or retardation or deceleration. So the acceleration of a body, it need not only increase, it may also decrease. It's basically the change in the speed or the change in the velocity. So that's about acceleration. Thank you.